Let's check back in with our timeline. So far, we have talked about the Cambrian explosion. We've talked about the Great Ordovician biodiversity event. We've also looked forward in time a little bit to see how these organisms evolved through time. But now we're going to come back after these two events and think about the rise of the fish. Okay, so we're starting in the early Ordovician. Vertebrates, which we've already talked about, those evolved during the Cambrian, again, had a segmented backbone or a dorsal vertebral column, a nerve cord. And in addition, vertebrates have a cranium or a skull that houses the brain, right? So we've got a skull with a brain inside of it and a spinal column with a nerve cord that connects our brain to the rest of our body, right? Those are vertebrates. All vertebrates, including primates like ourselves, are also members of the chordates. And notice that fish are also in this part of the phylogenetic tree, right? So at some part of their stage in life, all chordates have a stiff, elongate supporting structure, which we do, a dorsal central nerve cord, which we do, gill slits, which we do in utero, even though we don't have gills when we're born and as adults, when we are in our parent's stomach, we do have gills. So right, we have gills as part of our life cycle. And blood that circulates forward in a main ventral vessel and backward in the dorsal, right? So all of these things describes mammals, birds, reptiles, amphibians, and fish. Fish were actually some of the very first chordates. So the rise of the fish. We have 5 different taxonomic classes of fish. We're going to go through each of these together. The agnathans, these were jawless fish. Their mouths were often circular, kind of like a lamprey. The acanthodians, which were spiny fishes with jaws. Finally, they had that bony upper jaw and lower, or not bony, but hard upper jaw and lower jaw. There was also the placoderms, which were also jawed fish, but they had plate skin rather than spiny fins. And the evolution of the jaw was really no small accomplishment. It drastically changed how these fish were able to survive and the role that they played in the ecosystem. And this is because jaws allowed fish to bite and grasp and shred apart their prey. Right, so the evolution of the jaw allowed them to become much more ferocious predators. And the 3 that we've talked so far, the agnathans, the acanthodians, and the placoderms, these were the most frequently found in the early Paleozoic. After that, these next 2 evolved and became more common. We get chondrichthyes. These are fish with cartilaginous skeletons like sharks, rays, skates. So cartilage is like the stiff structure in your ear, right? It's firm, it's stiff, but it's still flexible, it's still bendable, unlike bone. So sharks, rays, skates, they have a skeleton, but it's that flexible cartilaginous skeleton rather than the hard bony structures that we have. And then finally, the fishes with bony skeletons evolved. And these were arguably some of the most successful, and they also allowed for the evolution of tetrapods, which are 4-limbed animals like us, right? So when you look at your arms and your legs, when you trace that back through the phylogenetic tree, through the family tree, through the evolutionary tree, you'll eventually make your way back to fishes with bony skeletons.